Got it. On. There we go. Well, welcome everybody to our February meeting of New Mexicans for Science and Reason. And our guest today is Leonard Tramiel, who is a software developer. I guess you were a vice president at Atari, and he worked with Commodore, did lots of neat software stuff. And more recently, he's been a member of the CSI Executive Council and a fellow. And
we are fellow fellows.
A fellow. And he's been doing marvelous stuff with photography and nature shots and whatnot. So today's theme is roughly, Marilyn can't hear anyone.
Everybody else hearing us okay?
Can you hear me, John Covan?
Yeah, I can hear you. Can you hear me?
I can hear you, Dave. Jerry Aldridge.
All right.
Let me chat to Marilyn.
Can't see her either.
Well, now she usually, to save bandwidth, she usually doesn't do the video because it really does gobble up your bandwidth.
Yeah.
Well, I hope Marilyn can hear, but I don't think it's anything on our end. I'm not muting or silencing
Up here, honey. Yeah.
Okay, so hope Marilyn gets her audio figured out.
Yeah, I got it now. Sorry. I don't know what I
great.
was doing wrong.
There we go. We can hear you.
Excellent. All righty. So so I had a couple things to start with. You want to just jump right into those?
Please.
Okay, so I'm gonna share screen. And okay, now I have to work my way over to that folder that I had. Window Science.
Any window labeled science is going to be good.
Oh, okay. But that's not the actual flat Earth. Well, no, that's
that sounds more dangerous.
sunrise. Okay. Well, I think I found a fun little sunrise video. Let me see if that goes. And yeah, this is in Socorro, New Mexico, right in front of the Latter-day Saints Church. And what this is going to show, the sun is behind you. You're facing west. And so the sun will rise in the east behind you. And if the Earth was flat, then as the sun got closer to us from the east, this tree would be lit up, and then the church, and then the last thing to be lit up would be the mountain, the farthest away. But on a round Earth, that's not how this works at all. On a round Earth, the first thing to light up is that M on top of the mountain, and then you can see the shadow of the Earth come right down the mountain, and then you'll see the sunlight finally spill into the church and the tree and the surrounding area. Here we go. It's a time lapse. So 1 minute is 1 second. So this took about half an hour. There's the shadow of the Earth coming down. And the church is still in darkness. Bam. And then finally, the last thing to light up is the closest. So that's something I need to bundle up and take on the road to YouTube to get out there to the flat Earth debunking community. But I'm intending on making some animations to show. Looks like we got somebody new to show. Okay, admit. Here we go, Randy. Okay, I want to make some animations to show what it would look like if the Earth was flat.
And another fun thing you can do with a similar setup is if you start a little earlier, you can actually see what's called the belt of Venus,
Oh,
which
yeah.
is the shadow of the Earth in the atmosphere.
In the atmosphere. I love that in the evening, but I haven't really, I'm not really a morning person, but I get
Yeah,
up.
but it has the disadvantage that you have to get up even earlier than you did to
Earlier.
take those pictures.
Oh, okay. So I'm gonna find.
So Dave, are you gonna send that to Shaq O'Neal?
I don't think he's a serious flat earther, but okay, pictures. Okay, here's the ones I was thinking of. So here is a neat little picture of Andromeda. So I hope everybody can see that, but let me zoom in. So this current time of year is a great time to observe Andromeda and basically find the great square of Pegasus in the west. And this is a great time of year and time of evening, actually, to do that. And then right up there is the Andromeda Galaxy. And what's recommended, this text here recommends that you wait, 5 minutes so your eyes get really dark adapted. Use a binoculars if you have one. But the actual Andromeda Galaxy is larger than the moon, the half a degree of the moon. If it was only brighter, and then we'd be able to see it easier. But worth taking a look at. So that's a project for perhaps this evening or next. I've got a bear on Mars, and here it is. That looks like a pretty good bear to me.
That's absolutely convincing.
Oh yeah, and so that goes under pareidolia. So I've got 4 of the Beaver Moon eclipse, and so this was November 19th, 2021. So not a year and a half ago. So here it is at various stages. 2:21 in the morning. This is 1:37 in the morning. So I made this sort of overlay. I took that picture where it was about half. I think I took this picture and 4:11 in the morning and rotated it. And then I looked up the Earth and Moon diameter, made a red circle that was proportionally the Earth's diameter compared to the Moon's diameter, which I got by scaling off the photo, and that matches pretty well. So to me, that's sort of suggests that perhaps this circle on the Moon is the shadow of the round Earth. And there's some great pictures that show what an eclipse would look like if the Earth was flat, and it's just a flat line. Some of them have the turtle on top, turtles all the way down. Okay, so there's your Beaver Moon, and
So looking at that picture, it looks like the actual shadow is just a shade smaller than the circle you drew, which is what it should be because the umbra of the shadow converges. So it'll be a little bit narrower than the Earth diameter at that distance.
excellent, yeah. All righty, so here's the blood moon eclipse. So
Ooh.
yeah, that's during totality, and this is, I think I had a harder time with this one. I think we had clouds, but that's always the astronomy photographer's challenge is clouds. But I just love eclipses because even as a child, I would stand there, looking at the shadow of the Earth crossing the moon, and it would make me feel like an integral part of the solar system. I could feel the sun at my back and the solar wind, and it just made me feel placed in the universe. Okay, here is an experiment I did with a friend on Twitter. And so I took this picture of the moon on January 13th, about a year ago, just after 4 p.m. And my buddy in Newmarket, New Hampshire, took his picture at 6 p.m. on January. It's quite dark. Night has already occurred, and this nice church that he used for a background shows, yep, it's just after 6 p.m. So the interest here is the poor flat earthers. They go around saying you can't see the moon in the daytime. The moon is the nighttime, and no, you can see the moon during the day almost every single day of the month. The only time you really can't is the few days around the new moon where it's just too close to the sun to see in day or night. So, but if the moon is recently full, then you can catch it in the morning. If it's not quite full, you can catch it in the daytime in the afternoon. And
Yeah, I'm
points
thinking
between.
I'm thinking of doing a series of images of the moon against as bright blue a sky as I can get
Yeah.
of for one consecutive lunar month.
Well, there's
Um,
a lunar analemma where you take a picture at the same time and then you add the moon's time, so the
Right.
just about an hour. So you
Yeah,
take
but you can't get
picture.
the whole thing at the
Yeah.
same time of day.
Yeah, that's going to be really tricky.
So not trying to get the analemma, but just pointing out that for the 29 days of the lunar cycle,
Uh-huh.
you can see the moon for just about all of them against
Absolutely.
a pretty bright blue sky. So really surprises people.
Yeah. And but what I thought was novel about this was it goes further to say, hey, one person's daytime moon is another person's nighttime moon. The moon is so far away that people on different sides of the planet, one in daytime, one in nighttime, can see it. And I really don't think the flat earthers appreciate that. Here is a picture I got of okay, I'm wondering why it's not okay. Now it's giving me daytime moon NM. Here we go. Yeah, there's a blow up with my I've got a Canon HS60. So it has a zoom of about 65, which is pretty good. It's not quite as good as the P9000 that the flat earthers really like. Here is another picture out in the hill behind where I worked at my last job doing seismometers, and there's the moon lurking in the distance. Okay. So here's a fun little experiment. Distance to the moon with your camera. And there we go. So here's the setup. Basically, this diagram shows how it works. You take a picture of the moon at midnight, and you also take a picture of the moon at dusk, at moonrise or moonset. And so, of course, full moon is what you want, so you can have the complete disk. So basically, the idea here is at midnight, you're right there, the moon's right there, and you are actually closer to the moon than at moonrise or moonset, when not only do you have this distance from the surface of the Earth to the moon, but you have the radius of the Earth. It's in there. So d primed is a variable you can call that true distance, and it's, for all intents and purposes, the moon is so far away that d primed is pretty close to d. So for the math, you can basically say we've got the distance to the moon is this d over here, and d minus radius of the Earth over here. And what that leads to is that at dusk, the moon, being the radius of the Earth farther away, is a little smaller. And at midnight, it's a little larger. So here's the math where basically you just measure the diameters, and of course you have to have the camera at the exact same zoom setting and f-stop and all that for the photograph, so that you're comparing apples to apples, moons to moons, and the math falls out, and you can figure out the K factor. Basically, that ratio of the pixel sizes, it's just slightly over 1. But when you compute K over K minus 1, that gives you, in this case, for the pixels that I found, about 63. It's actually about 60 Earth radii. So I was about 5% off. Here are the pictures. This is the moon at dusk, 2,496 pixels. And this was Halloween 2020. And here it is, the midnight moon, and 2536 pixels.
Dave, I got a question.
Yeah.
Would you consider redoing those calculations for when the moon was first formed and it was ever so much closer to the Earth?
Ooh. Well, you'd have to go back in time. I mean, that'd be a fun experiment, but I don't have the Wayback Machine, you know. But yeah, fascinating.
I guess it was claimed that it was, what, 15,000 miles away from the Earth or something in the
Yeah,
beginning.
much closer. Yeah. Yeah, that would have been a sight to see.
Probably
Okay.
would have been hard to stand on the Earth's surface at that point,
You would have toasted your Tootsies.
at least.
Okay, so here's some eclipse photos. Oh, this one right here. Let me embiggen it. Yeah, so this one is actually taken from by some creationists, the David Rivas Ministries, and most of the time they're bashing evolution and whatnot, but they realized those flat earthers, those guys are nuts. And so they went and took a picture of that great eclipse, August 21st, 2017. But they let the corona just be overexposed, and that allowed the detail of the moon. You can see there's the very new moon illuminated by the very full Earth, which is facing it. And this is great evidence against the flat earthers, because the flat earthers, when you press them on what is an eclipse really, they'll start talking about Rahu and Ketu, and they don't even consider the moon as an object that reflects light. They think the moon gives off its own light, and it's really hard to pin them down. But with this picture, and you can show them, hey, this is from the creationists. Even they think you're daft. But that picture really does nail that it's the moon that's that funny thing that makes the sun go away in a solar eclipse. Okay. And so this is an annular eclipse. A few years ago, we took a picture in Albuquerque, and what I've got is just a binoculars. And if you hold it backwards, so that the front end of the binoculars is facing the sun, then you can project a nice image of the sun. It's much more powerful than a pinhole reflector. You have to have a really big pinhole to get an image that good. And yes.
I hate to interrupt on this picture, but the previous picture, the moon at full solar eclipse, has anybody ever, wouldn't be a flat earther to do it, and wouldn't occur to them to do it, but has anybody, to your knowledge, taken images of, not images, but measurements of the moon at full solar eclipse in the infrared, around 15 microns or so.
Wow.
So you got going through the Earth's atmosphere twice a ditch at 15 microns, and then you would see the water stuff, on the fringes of that, and then you would see the full solar illumination in the gap from 8 to 13 microns.
That sounds like
It just dawned on me. Has anybody ever looked at that?
that sounds fascinating. One thing that the flat earthers do contend is that moonlight is cold, and that if you shine moonlight on things, it cools them off, because somehow moonlight is
It
meant
draws the heat out.
cold. Yeah. And basically when you look at these experiments, what they've got is they have something inside or covered up, so they do not control for air currents or anything like that. So when it's not surprising that they're not getting consistent measurements at all, but that would be an interesting one to handle.
Yeah, you'd
so
really have to be careful not to get scattered light from the corona, but
yeah, and to have absolutely identical conditions to measure where the moon is shining and where it's not shining, to see if where it's shining is actually colder than the dark.
yeah.
So that'd be a fun experiment. Here is the shadow of a little colander that I took during the August 17th eclipse, and you can see each of those little circles has a little picture of the sun in eclipse. That's a fun thing to do with colanders. And I went to the elementary school that day and gave the kids a little demo. I had the projector out. There were several astronomy enthusiasts with scopes and whatnot, but I brought this physical model so I could show them that the moon's orbital plane is tilted from the Earth's, and it's only when they line up at this axis of nodes that you have a decent chance of getting an eclipse, and why, if these two planes were coplanar, we'd have an eclipse every single month, solar and lunar, but we don't. So I think that was a interesting little model to help demonstrate that, and I was aided greatly by these banana holders from Smith's. They're just a little plastic thing, you hang your bananas on them, and I thought that is the bomb for holding up your astronomy demos. Okay, so let's see. Life water. This is just a random JPEG that people send me. This is a product you can get, pH balanced water. Well, I hope it doesn't cost too much. Wow.
I wish I had taken a picture of it, but many years ago, I was in a Whole Foods and there was a container, a whole display area of different kinds of overpriced waters. My favorite was the fact that the oxygen enriched water was right next to the antioxidant water. Of course, both of them are good for you. And if you mix the two, you get water.
Yeah, my question would be, how long would it take for the life water to eat a hole in the jar?
Yeah, that's a good question. Those are great questions. Okay, here's one that I got in couple of years ago, the transit of Mercury. We were in Austin, Texas for a big birthday party for one of our band members and his record label. Blue Corn Music was having a big celebration, and so we got to see some great music. And then the next day we were catching a plane, and and I knew, Mercury transit, and it was just cloudy, so I finally, I think right outside the hotel, it was kind of really hazy, snapped a few pics of the sun. I looked at the little viewfinder, nothing. And I said, oh, darn, I missed it. And so then I got home, and then the next day we were, back in Socorro, and I was looking at that picture, and I went, wait a minute, that's Mercury right there. And so I just, wasn't able to tell on the thumbnail that I'd actually gotten the shot. There it is. So that was good fun. Kind of a serendipitous occurrence. Okay, we got I'm going to open these two. Now this was on Twitter the other day. The Space National Weather Service, or actually the ISS, post these, International Space Station. They were tweeting this to the attention of New Mexico, Albuquerque government, KOAT, KOB. And let me try to enlarge that. There we go. Oh, now the zoom controls are getting in the way of the picture controls. Oh, okay. So this is the picture NASA had, and I just really had a little trouble orienting until I saw Mesa Prieta up there, and that is such a great landmark. And so here I've got just a Google Earth picture with the satellite terrain turned on, and I rotated it so you could see Mesa Prieta there, and now it's got all the landmarks, so you can see from this. Okay, there's Albuquerque and Canyoncito Indian Reservation, and everything is a little more intelligible. So thought that was kind of neat to be able to track that down. But yeah, those landmarks are great. Okay, here's a couple on field rotation of the moon as the moon orbits from moonrise to moonset. It's rotating, and actually it's the Earth that's the one that's turning, but from our perspective, up being up away from the Earth, it looks like the moon is the one that's turning around. So here we have south at midnight, and here we have just after moonrise, I think. And so here's Mare Crisium Tycho on the bottom, and setting moon, Mare Crisium is all the way down there. Yeah, and that's the intermediate. So this is moonrise, about midnight, and moonset. So you can see that moon just field rotating right around there. And we were some folks in New Zealand were doing some observations at the same time. I am a sucker for mountains and moons. Oh, here we go. So here's a picture I got of our Socorro Peak M Mountain with the setting moon in the background, and that nice windmill, and the rosy fingered dawn. Same picture. Here is one at night, showing not only the moon setting behind M Mountain, but they light up the M for events like first and last day of school. So I got the M with the moon. That was kind of an Emmy kind of day. And here's one I really liked of the moon setting behind one of the antennas on the mountain. So just a neat view of that. So I find a bicycle is a great tool, because on your bicycle, you're outside, you can see where things are, and you can say, whoa, if I was just a half mile down the road, the moon would be coming right down the mountain where I need to be. And there are some apps that will help you do that, where you can just play, where's the moon going to rise tomorrow from where I am right now, and it'll show you where, where to take the shot. So this, oh man, it's hard. That right there is Comet Neowise. It's pretty damn, I think that was just a photo with the phone. And here's a recent one I got of the occultation of Mars. And that was a cloudy day. I thought we had really just missed the whole thing when the moon crossed Mars, totally cloudy. But after an hour or so, I went out and saw clear skies, beautiful moon, not a hint of Mars. So I got the camera and out and got the shot. So that was fun. Unexpected reprieve from the sky. And let's see. This is a neat little sky map that you can get from, where is it from? Anyway, it shows you for each month, you can get a printout, and basically it'll help you locate and learn your constellations. Sky maps on Twitter, twitter.com, sky maps. Yeah, and there's the URL, skymaps.com. So that's a great handy resource, and they got these neat charts that print out on an 8.5 by 11 for those people that like that sort of thing. And here is a picture of the transit of Venus. And I had one of those solar, like the binocular projectors. Oh, and I was getting some money at the ATM and realized, wow, this setting sun, we won't see Venus transit for another, I don't know, 100 years. And got the camera out, got the picture, because we won't see that again for quite some time. Do you know when, Leonard?
Not off the top of my head. It's going to be a while.
It's going to be a while. Probably won't be around for that one. But that was great fun. That is the ones I've got. I've got some astronomy ones. I had a really neat one that a friend did of a video of Orion and the Pleiades rising, and mainly to show that it comes up from below the horizon. The flat earthers are really confused about, they'll say, well, if the earth was on one side of the sun and then on the other side of the sun 6 months later, you wouldn't see the same constellations. And of course, that's absolutely right. Orion is a great winter constellation, not so much in the summer. But what they don't realize is it's like if you were in a room and you were looking west, east, north, and south, and 6 months after you were looking west, while you had to look east, and you couldn't look behind you because that bright sun's there. So you would see, different sides of the room at different times of the year. But at any time of the year, you could look up at the ceiling of the room, and in this case, what you'd be seeing is Polaris and the Big Dipper, and those constellations close to Polaris. You see those year round, unless you're in the southern hemisphere, and then it's the Southern Cross that you'll see year round. So I do have one possibility for looking at those, and that is on our website. So I don't have the photographic version, but I do have the animation. The sun never sets. Spotlight. I think that might be the one. Oh, so this is one of our articles on the NMSR. Yeah. And this, this is just the sun and sunrise. I don't think I've put the star trails up yet, so I need to do that. But basically what this shows you is, so this is a little Python animation I made. We're looking at the whole sky, from south all the way through north to south again. Just sort of a linear, each 30-degree chunk of sky is has its own square. And what we can see is and this is from minus 43 degrees. So that's like New Zealand. And what we see here is that the moon rises, or not the moon, the sun rises, goes high, and it's the sun is always moving from east to north. But in the southern hemisphere, you're looking north, you're not looking south at the sun like we do up here. This green object is the flat Earth sun, which basically you just take the flat Earth model and project what would this look like if you were looking at it. And the flat Earth never sets, never goes below the horizon. And it certainly isn't where it's supposed to be. You can go out and measure where the sun is, and it certainly fits this red diagram. Oh, lots better. And you can see that the flat Earth, the size varies a lot when it's far from you. And here it's the farthest and lowest apparent position, just a little dot. But as that flat Earth sun comes around and gets closer to you, it gets bigger, which is not what we see when we look at the sun. It's the same size in the morning as at noon, as at sunset. So here's that flat Earth sun getting much bigger than the actual sun. So I regret I don't have that Orion picture. It's just been a pretty crazy week. But that is the science and photography that I had.
So Dave,
Yes.
I did find a picture that I'd like to share.
Excellent. So I'm going to stop sharing, and I'm going to anoint you with host power.
Oh my gosh. I
I
will try not to abuse it.
make a co-host. There you are.
All right.
So now you should be able to share screen.
Right.
So, and if it's a movie, remember to click on sound.
Yeah, it is not.
Okay. Oh, beautiful.
So do you see it?
Yes. That is beautiful. It's not
So
sure. It's,
it should be a great egret.
great egret. Okay.
Is that what you see?
Yes. Fantastic picture.
So what's happening here is the bird is about to land, so its wings are stalled, which produces a great deal of turbulence on the upper surface of the wing.
Huh.
And you can see the feathers are, so can you see my cursor?
Yeah. Yes.
Yeah, so you can see here and along here,
All sorts of
the
turbulence.
feathers are being pulled up by the turbulence on the stalled wing,
That is really neat.
which is kind of cool.
Excellent.
I had no intention of, no thought that I was going to capture a pedagogical photograph, but I just saw this great egret coming in for a landing and took a picture,
Excellent.
which is kind of cool.
Nice shot. It's great. It's great when you get the shot.
Yeah.
Leonard,
Yes.
this is Randy Truman. I'm a aerospace engineer, so I have
Hi,
a
Randy.
question. You said turbulence.
Uh-huh.
Do you mean turbulence or do you mean separated flow in this form of vortices?
That's what I mean.
Okay,
Turbulence is a very vague term in everyday parlance. I don't mean turbulence as an aerodynamicist would use it.
Yeah, because the vortices, you might even kind of overlay your picture with how vortices might be oriented,
Right.
or that are separating from that leading edge.
Yeah.
And perhaps going unstable and eventually downstream reaching turbulent state.
Right.
I was interested by the disturbance seems to be kind of mid-length of the
Right.
span.
Going down from here to about there.
Yeah, not at either end.
Right.
Of course, the feathers on the end of the wing, wing tip,
Right.
controlling that flow
Yes.
and providing stabilization for lift and things like that.
Yeah.
It's a wonderful picture.
It's amazing how much real aerodynamics goes into a flying bird. I wonder who taught them how to do that. Yeah, that's a fun one.
Excellent.
Yeah, so the other thing that I wanted to mention, which I don't have any pictures for, Dave and I were talking the only time we've seen each other recently in actual person, about an experiment that a bunch of flat earthers living scattered around our world, we won't say around the globe because that might disturb them. You'd have to pick the locations fairly carefully, but if you got someone at around 45 degrees north, someone near the equator, someone around 45 degrees south, all looking at the moon at the same time, pick locations where the moon would be near the horizon, pick a moon that's right around first quarter where there's an obvious north and south pole that you can see, and just draw a line showing the angle between the horizon and the north and south pole. Those would rotate by 45 degrees between those three photographs. And it can't be the moon doing the rotation, because it's the same moon you're looking at in the same sky. And the only possible reason would be because the Earth's surface is at a different angle at those three locations. I suspect that they would figure out some reason to ignore that suggestion, but I don't see any way that can be consistent with anything other than around Earth.
That's a nice one. Okay, I found a wildlife picture I got. So let me share that. And there it is. So this is down at the Bosque del Apache in just by San Antonio, New Mexico. And so here was a whole flock of just regular could be ducks or geese, not quite sure, but this guy, they might have been a little perturbed by that.
Yeah, maybe slightly disturbed.
Oh, I enjoyed getting that shot. Yeah, it's a great spectacle in the depths of winter. Just thousands and thousands of geese and
Aren't those cranes? Look
these
at the red top.
global cranes. Yeah, yes. So maybe they are cranes. I believe they are.
And
And
that's
the black
Harrier.
tips on the
Okay.
wings. Yeah.
Yeah, that looks like a northern harrier.
Yeah.
So there,
Got
yeah.
the white patch on the tail.
Yeah, that was a fun one. Okay. All righty. Anybody else have any photos of note or just for fun? I've got my cloud opened up. See if I can find some more bosky pictures. Not really. Yeah, I don't really have any handy, just sitting around. But that was certainly fun. Leonard has some great ideas for future experiments. I want to do the measurement of the temperature of the moonlight. That would be a fun one. Another flat Earth claim is that you can only have rainbows because of the dome, and so when you spray your garden hose and see the rainbow in your hose, that's because the sun is somehow reflecting off the dome. But the claim is you cannot make a rainbow inside without the sun. You have to have the sun and the dome together. And it's actually pretty darn hard, even if with a very bright light. But I think I'm gonna, try that and see if I can get a nighttime rainbow in a dark room with a very bright light.
You could do the rainbow with the garden hose at night.
Yeah, absolutely. You'd have so I'm going to do it in the bathroom because you can get quite dark in there, and we've got a tile floor with a drain, so we're not making a big mess.
Yes, that would help.
Yeah, that's my plan. We've got some big light bulbs. I just need to get some time where I'm not doing all sorts of things. Looks like Marilyn dropped out, but she is back. Okay. All righty.
What would happen if you would use a flashlight?
I just don't think it's going to be bright enough. You'd have to have a hell of a lot of lumens.
You'd have to have a very bright flashlight, and it would have to be incredibly well collimated.
So I'm thinking of a really bright light source, but with a screen with an aperture to let just some light through, and then putting the spray there where you can.
Yeah, as long as you can,
as long as you
control the angle.
Yeah. Oh, of course, you have to have the angle, right?
Yep.
Because the rainbow only happens at that 42-degree angle, plus or minus. Alrighty. So I encourage everybody to try to see Andromeda. And did anybody have any luck seeing the or that recent comet, the so-called green comet? I saw it a couple nights. It was really hard. It was a lot harder than say Neowise. That was a fine little comet. Of course, nothing like Hale-Bopp or Hyakutake, but it really took some effort to get this CZ7. Just not that bright a comet. Did you have any luck with that one, Leonard?
I did see it. It was nothing spectacular. It was, as you said, pretty hard to see and much less visible than Neowise.
Yeah.
I was just amazed at the number of people that would send me emails or texts or call me on the phone and say, "Did you see the green comet?" Yeah, you realize that under the right circumstances, all comets are green. And they went, "No, really?" Yeah. So it was not unusual that it was green. It would be unusual if it weren't green and not particularly bright. And people were going, jumping up and down saying, "The best comet of 2023. How do we know that? It's only February.
Yeah. Well, if that's the best comet, then this isn't one of the big comet years. Then.
Yeah, not a good comet year. People don't remember Hyakutake was discovered 3 months before it skimmed Earth.
Wow.
So, and on one night, Hyakutake was just amazing.
Oh yeah, that was a really spectacular one. The wife sort of teased me. She'd say, "What are you doing? I'm gonna go see the comet. What comet? Hyakutake. Bless you. She'd make me say the name just so she could say, bless you.
That's a clever use of language.
Yes. All righty. Well, anybody else have any good yarns? I have some sort of sad news about John Gohegan, our former vice president, has taken ill and he's in hospice. So
Oh dear.
yeah, a couple of us are gonna go try to visit him Friday. So if anybody wants to tag along on that, let me know. But Kim Johnson and I are gonna try to visit him while we can, because I don't think he's gonna be very long, according to his wife, Janet. So that's kind of sad. All righty. So I guess we'll wrap it up. That was mighty fun. And I've got some ideas for future projects.
Thanks for
And
the invite, Dave.
yeah, thanks for coming along, and great discussion. And we'll keep in touch when I get around to doing the Foucault pendulum experiment. I'll let you know how that works out. Here at Tech, we've got a pretty nice 10-meter area, 10 meters tall, that we have a balcony on top. We can hang something down. It's certainly not big enough to let the pendulum, rotate for 360 degrees. But what we want to do is just have the pendulum swing for about an hour. And in that hour, at our latitude, it should take about 42 hours to make the full circuit. So in 1 hour, we're looking for like 8 degrees of motion. And it's of course going to be in a certain direction. It'd be in the opposite direction in the southern hemisphere. And that's one of the things the flat earthers criticize Foucault. They say, well, you don't get consistent results. Sometimes it goes this way and sometimes it goes this way. Well, yeah, depending on the hemisphere, that's how it works. So, but they'll basically, pseudoscientists will find anything that looks like perhaps a conflict or an error, and try to capitalize on that.
Have you watched the pendulum in Washington, D.C. at the Smithsonian?
Not in person.
That was really cool.
Yeah, I've seen that. It's really quite striking.
How tall is that one?
It's big.
And it's got an electromagnetic kicker that keeps it going.
Yeah. Neat. Well, we got a pretty nice ball joint to let it go around with. So we're hopeful it'll still be pumping after an hour without any additional effort. Okay.
That'll be fun.
Okay, Marilyn says she was having some technical issues, but she did get back on. Alrighty, Tish says fun. So I'll let you know what we're gonna have for March. Of course, the Ides of March are coming. Big day for Caesar salad.
Can I ask you guys a question?
Yes, you can.
We've been having a lot of trouble with the internet, with our TV. Everything would just wink out, and it turns out my neighbors have been too. And that's why I lost you for a few minutes. And I don't know if anybody else has been having that trouble or whether it's just in our area. Anybody else?
Has anybody had dropouts like that? We've been pretty steady down here in Socorro.
About a week or so ago, we couldn't get anything. No internet, no TV. It just wouldn't work.
And did you call your provider, your
Oh,
ISP?
yeah. Yeah.
And did they acknowledge that?
Well,
there
they
was
came out here,
problem?
and by then it was back up working just fine.
Darn.
It's space aliens, no doubt about it.
It's
Yeah.
those balloons. That's
Yeah,
what
it
they're
must have been the
doing.
balloons,
They're
absolutely.
jamming our signals. So because Joe Biden shut them down, that's why you got your TV back.
Okay.
that I can't explain
Blame the
tonight.
president.
Or either that, or because Joe Biden shot him down, they had to jam even more powerfully. And that's why you lost your internet today.
There's an explanation for anything.
You can always tie paranoia into anything.
You bet. Alrighty, well, thanks for coming, everybody.
Alrighty.
I will see some of you next time, and have a great rest of the month there. Okay, take care, everybody.
Nice to see everybody.
Thanks, Dave.
Thanks.
Thanks, Leonard.